Alright, so today we're solving equations by completing the square. The story goes something like this. Recall something about the square root property. If you remember, the square root property idea went something like this. If you have x squared is equal to 25, that's your given equation, we could always jump to getting rid of that square by doing plus or minus the square root of 25. That is the world famous square root property, right? And of course sometimes you can go one or two steps more if this is something that you can handle. In this case, the definition of radical says that's the positive real number whose square is 25. 5 fits that bill, so we've done. That's the good thing. The good thing is that the square root property works well when you have x squared is equal to whatever, blah, on the right hand side. As long as there are no x's on the other side, the square root property is good, very good. Square root property, 1 plus 1 for that. Alright, that's the good thing. Now the bad thing might be something like this. Let me consider, oh actually this is also, it's also really good here. Here I can get rid of the square by doing x minus 3 is equal to plus or minus the square root of negative 7. This is by square root property. And that would give me that x minus 3 is equal to plus or minus I times the square root of 7 by definition of negative radical. And there you go. Oh, I can add 3 to both sides. So that would make 3 plus or minus I times the square root of 7. Cancellation law of addition. I added 3 to both sides. You can think about it this way. I added 3 to that side and I added 3 to that side. That's how I got 3 plus or minus these ones. Alright, that's when it works really well, square root property. When you have x is all inside the square, square root property is really good for getting rid of that square. Now for the bad would be something like this. When you don't just have an x inside the square, but in addition to that you have another x somewhere else. Could be on the other side or there. There it's not going to help you. I mean, you could try, it's still true. The question is whether it's helpful anymore. I could say x squared is equal to negative x plus 25, that's by cancellation law of addition, adding a negative x to both sides, and I could say, well, that means x equals plus or minus square root of negative x plus 25 by square root property. Now, while that's actually true by square root property, it's not as helpful because we haven't really solved for x. If you take a look here, x equals some other stuff, but you still have x's in there, so it's not really what we call solving for x. That term right there, solving for x, we reserve to when we've isolated x on one side and no x's on the other side. So that's the problem with the square root property. It works really well if you only have one x or one term with x's squared. It doesn't work as well when you have a few x's there. But don't worry, I got some excellent medicine for that. And so for that we take a look at the following idea. Yeah, here it's not going to be good. Look, you have x's here and x's there. No go. The square root property, while it's still true, won't be as helpful. Here's the fix. The fix for us is to complete the square. So take that previous example there. Watch how amazing this idea is, and it will cure all our problems. Now let me just write the idea here on the side so we don't forget it. I'll remind you, the perfect square, which is also we call Pascal polynomial number 2, went something like this. If I have x plus y and I square it, I get x squared plus 2xy plus y squared. That's pp2. Now if you have forgotten how to get that or where that came from, you're welcome to FOIL that out and you see you get that answer, that expression. In fact, this was on the previous, it's been on previous sections. One when we multiplied famous polynomials, another time when we factored famous polynomials. So you should be well versed with this pp2. Anyways, if you're not, here it is again. Super important, pp number 2. Now the idea is to make this creature right here match that. You're going to be looking out for the right hand side. Anytime you have x squared plus 2xy, you can exchange it for the left hand side, and you don't have to be so caught up on making sure that it's x and y. They could be anything. It could be x squared plus 2 times x times p plus p squared. Here, instead of having y, I have p. So what? Then the answer would be x plus p squared. Really, they could be anything. They could even be numbers. I could have 8 plus 2 times 8 times 5 plus 5 squared. You see, I have perfect square at the beginning, a perfect square at the end, and 2 times each of them in the middle. So therefore this must be the same thing as 8 plus 5 square. Check it if you don't believe me. You see why they pay me tons of money. This will be okay, I promise you. Alright, so the idea is to look out for this perfect square that you can exchange for the binomial, this 2 terms binomial squared. Again, one more time, if I have anything square at the end, and I have 2 times each of them in the middle, they could be in either position, so long as I have 2 times one of them and the other one of each of these, I have winner winner chicken dinner, a perfect square, PP number 2. Most people call this a perfect square. I think it's better to call it Pascal polynomial number 2 because it's part of a bigger family, Pascal polynomial number 3, etc. Anyways, the trouble is that sometimes they only give you a piece of this and you got to fill in the gaps. So for example, they might only give you 2 times x times, I don't know, 3. And then you say, whoa, they only gave me a little piece of the PP number 2. I got to supply the other piece of the PP number 2. So even suppose they only give you this piece right here, then you know that what you're missing here is a 3 square and an x square. These are sometimes missing and you have to supply them. That's why it's called completing the square, adding the missing ingredients so that you have a PP number 2. And then once you have those in there, then it becomes beautiful as x plus 3 square. Now, watch how that applies to this problem. Amazing that this idea would help us solve this one. So I break this up as x squared, and then instead of writing 6x, I write 2 times 3 times x plus, and then I leave some space here for my missing item, -7, and I try to think, what would my missing item be? I have a 2, a 3, and an x, and I have an x squared. I think that the missing item to make this pattern to make this one fit this pattern would be a 3 square. If I had a 3 square, I'd be in luck there. To make it legal, I will add it to both sides. And I quote cancellation law of addition says I can add that to both sides. And now I'm in good shape because on the left hand side I have exactly the PP2 pattern. So therefore I have x plus 3, the quantity squared, and on the right hand side I have -7 plus 9. So on the left hand side I did PP2. On the right hand side I did very simple things by inspection. That becomes x plus 3, the quantity squared, is equal to 2. Again, on the right hand side by inspection. And now look what we've done. We turned it into one of the good ones where you just have one x. You see any more x's here? You put them all inside the square. That right there is beautiful. Because now I can get rid of that square using my excellent medicine for squares. It's called the square root property, SRP. And now I can just subtract 3 from each side. Yippee-ki-yay. Beautiful, huh? That right there is the secret right there. It doesn't look like a perfect square. You add the missing items. You add the missing items so that it turns into a perfect square. Then you can use the square root property. That right there is amazing. This will help you solve countless degree 2 equations. Alright, that was so fun. We should try it again. Yeah? Let's try it again maybe on a different problem. How about that one? Again, I'll remind you, what we're trying to figure out, what we're trying to do is complete the square. We're trying to complete an expression that looks like this. X squared plus 2 times blah times x plus the blah square. Because I know I can exchange that for x plus blah the quantity square. So here we go. I got x squared, check. I have 2. How am I going to get a 2 out of here? Well, the 10 could be broken up as 2 times 5, but just so I don't hide the patterns, I'm going to make a note to myself that I get the 5 by taking the 10 and dividing by 2. Right? So because other times this number may be odd and then you're not going to know what to do with. So this will remind you that all you do is divide by 2. And then I'll leave some space here, and then -7, and I'll leave some space here. And this is just by inspection. And now I'm ready to supply the missing item. I have the x squared, check. I have the plus, check. I have the 2 here, check. I have the blah here, check. I have the x here. What I'm missing is this piece. Whoops, no, check there. I'm missing that one. So I need to add a 10 over 2 square, a 10 over 2 square. That's the missing item. And I can do that by cancellation law of addition. And now that's beautiful because I have x plus 10 over 2, the quantity squared, and that's equal to -7 plus, of course, you can clean it up now. This is 10 over 2 is 5. This is 25. PP2 on the left hand side, by inspection on the right hand side. And clean it up some more. X plus 5 squared is equal to 25. Take away 7. Well, first I'm going to take away 5. That'll leave me with 20. Then I take away 2 more. That'll leave me with 18. That's nice. That's really, really nice, because now I have perfect squares equal to 18. And we have the perfect medicine for perfect squares. We know exactly how to get rid of that square. It's SRP. So the x plus 5 is equal to plus or minus the square root of 18 by SRP. And there we can subtract 5 from both sides, leaving us with x minus 5 square root of 18 by cancellation law of addition and some other minor axioms. And just for fun, the other thing you could do is you could clean this up sometimes. Remember, what are your favorite squares? 4 is a perfect square. 4, 9, 16, 25, 49, 64, 81, 100. All these are perfect squares. And I think one of those goes into this one. 18, I can see a 9 in there. So I can maybe split it up into like this. Square root of 9 times 2. This is by times table. And then this will x equals negative 5 plus or minus the square root of 9 square root of 2. This is by radical of the product is equal to product of radicals. And this is x equals negative 5 plus or minus 3 times the square root of 2. By definition of radical, the radical 9 is a number that when we square you get 9. 3 fits the bill. Yippee-ki-yay. There you go. Beautiful problem. So if you were walking on the street and somebody stopped you and said, hey, excuse me, can you tell me, if I have a number and I square it and I add to it 10 times the number and I get negative 7, can you please tell me what's the number? You say, well, of course I can tell you what the number is. The number is 2 possibilities. You have either a negative 5 plus 3 times the square root of 2, or the other possibility is negative 5 minus the square root of 3 times the square root of 2. And moreover, those are the only 2 possible choices. There's no other real number that works because of fundamental theorem of algebra says degree 2 warrants 2 solutions, and we've got them. That's it. It's a beautiful story. Alright, should we try one more? We're on a roll now. I feel like we're on a roll. I think we should try one more. Just to make this... that one's too easy. That one's too easy. Oh yeah, we should try an odd one. How about that? That number is odd, so it might be more interesting. Or some of these other ones. Alright, I think we should try... Oh, that one's got a 3 in there. That makes it even more interesting. Oh, okay. Let's try this one then. Yeah, let's try that one. So let's forget about that one. Let's do this one. So this one I have 3x squared plus 5x is equal to 2. That's by cancellation law of addition. I added a 5x to this side and I added a 5x to that side. The cancellation law of addition says I can do that. What I'm doing here is getting all my x's on that side. Now keep in mind, I want to complete x squared plus 2 times something times x plus something squared is equal to x plus that something squared. That's what I want. You got to keep your eye on the ball. That's the famous PP2. And here I've got a 3, so I don't want any 3's here. I want just x squared. How could we get rid of the 3? Well, there is something famous. It's called slapping a third on both sides. All right, and that's justified by cancellation law of multiplication that says I can multiply both sides by something. Then I would distribute this, and so I would get x squared plus 5 over 3x, and that's equal to 2/3, and that was done by distributive law, right? Alright, so I've got my x squared matching, check. I got my plus, check. I need a 2 here. I need a 2 here. I don't have a 2 here. How can I get a 2 there? Well, again, the legal way to get a 2 there would be to just put it there, but as long as you put it over here, 2 times 3 on the bottom, because that way they would cancel each other out, and you haven't changed the value of the number. You just change how it looks. You put a 2 on the top and a 2 on the bottom, they would cancel 5/3. It's still equivalent. But this gives you a big hint as to what your missing item is. You see, I have an x squared, check. Really? Really? No, not right now. Sorry. Telemarketers. Alright, where were we? So this is the missing item, so I know what to add to both sides. I'm going to go ahead and add. Sorry. Alright, so we've got the little hint about what's missing. That guy is the one that goes in the middle, so that guy square should be the one that goes over here. So we will add another color here, and we will add a 5 over 2 times 3 square to that side. So long as we add it to the other side, we will be fair about it. It's cancellation law of addition that justifies us adding numbers to both sides. And that completes the square on the left hand side. And that turns into something nice. It means x plus 5 over 2 times 3. The quantity squared is equal to 2 over 3 plus, I could do this in my head, 25. 6 times 6 is 36 by inspection, and pp2 on the left hand side. And the rest of that is grunt work, x plus 5 over 2 times 3 squared. I think we can get a common denominator. I think I'll do 12, multiply top and bottom by 12. That'll give me 24 over 36 plus 25 over 36. Just so I can get a common denominator. That step is optional, but I guess you could if you want. 5 over 2 times 3. I could write 6 too. Sometimes I don't really like to write 6 because it's pattern hiding. Anyways, it looks like 49 over 36, I reckon here. So then we use SRP, square root property, would say that x plus 5 over 6 is equal to plus or minus the square root of 49 over 36. Now look at that, isn't that nice? Those are actually famous squares. 7 times 7 is 49 and 6 times 6 is 36. So I could simplify it yet one more time to say this is plus or minus 7 over 6. That's by definition of radicals. This one was by SRP. And here we go some more. X equals negative 5 plus or minus 7 over 6. Cancellation law of addition. It's beautiful. That right there is the solution. I've got x, degree 2 solutions, degree 2, 2 solutions, one for the plus, one for the minus. I guess you could get a common denominator and add that 5, negative 5 plus 7, 6 if you wanted to. Anyways, I think this gives you a nice idea of the power of the PP2. It's your turn now. You got to do a lot of these. Hopefully this helps. We'll see you guys next time. Peace.